Hello, welcome you all. In this video session, we will derive the response of the mass spring damper system subjected to forcing function by the graphical method. In the last session, we have derived the response of the system, that is x max is equal to x naught divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square, where x naught it is the zero frequency amplitude, that is equal to f naught by k. Omega by omega n it is the frequency ratio, where omega it is the natural frequency of the system, omega n it is the natural frequency of the system, and zeta is the damping ratio. In the today's session, we will derive this response of the system, that is this equation, by the graphical method. Okay, let us assume the displacement of a mass, that is x is equal to a sine omega t minus phi. To represent all the forces and displacement, we need to consider the same trigonometric functions. So x is the displacement. Let us find the velocity component and the accelerating component. X is equal to a sine omega t minus phi. In our equation of motion, we have mx double dot plus cx dot plus kx is equal to f naught sine omega t. So we need to find velocity component and accelerating component. The displacement component, it is assumed here a sine omega t minus phi. Okay, differentiating this displacement component, we can find velocity component, that is a omega, differentiation of sine it is cos omega t minus phi. Okay, as we are representing all the forces, all the displacement in graphical form, we need to consider the same trigonometric function. Let us consider sine function. This velocity component, now it has cos function. Okay, by adding 90 degrees or pi by 2, it can be considered as the sine function. See here, a omega sine omega t minus phi plus pi by 2, adding 90 degrees, it is a sine function. Okay, similarly, differentiating the velocity component, accelerating component can be determined. So a omega, differentiation of cos it is minus sine omega t minus phi. Already it is in the sine form. Now let us find the forces. There are four forces are there. One, it is impressed force, that is f naught sine omega t, and other three forces are spring force, damping force, and the inertia force. We already know that spring force it is kx. Substituting the value of displacement component, it is a sine omega t minus phi. Damping force cx dot, substituting the value of velocity component, it is c x dot, it is a omega sine omega t minus phi pi by 2. Okay, all the forces are considered in the sine function. Similarly, inertia force mx double dot, it is m. What is the x double dot? It is a omega square sine omega t minus phi plus phi. Okay, see here, now we have all the forces, it is in terms of sine function. Okay, let us represent all these forces in the graph. The impressed force, that is f naught sine omega t. Okay, this f naught, or it is the reference axis. From this axis we are considering all the forces. Okay, the impressed force f naught it is the magnitude, and it is at an angle omega t. It is at an angle omega t. So it is f naught sine omega t. We are considering all the forces as the sine function. So this is the reference axis. By this axis we are considering all the forces. Now the displacement, the assumed displacement x is equal to a sine omega t minus phi. Okay, what is the angle here? It is with respect to omega t, it is minus phi. Okay, so the displacement x, it is made an angle omega t minus phi. Up to this it is omega t, this much angle it is omega t minus phi. So this angle it is omega t minus phi. Okay, this is the x displacement. Always opposite to the direction of the displacement there is spring force. Okay, the spring force, it is directly opposite to the displacement. Okay, the magnitude it is kx, and the angle will be the same, omega t minus phi. Kx, see here, kx, where is the spring force? Spring force, it is ka sine omega t minus phi. The angle will be the same but in the opposite direction. Okay, it is with respect to this, it is also the angle is same, omega t minus phi. And what is the relation between damping force and spring force here? See here, the magnitude it is ca omega, and the angle it is damping force, it leads 90 degrees by the spring force. So it is at an angle 90 degrees. So to this force we are drawing a line or the force vector, it is 90 degrees. See, it is c omega x, 90 degrees. You can see in this equation the magnitude of the damping force, it is ca omega. Okay, for the spring force it is omega t minus phi. Here it is omega t minus phi plus 90 degrees. So this is, it leads by 90 degrees. Okay, 90 degrees. With respect to spring force, this force, this damping force, it is drawn 90 degrees angle. Okay, similarly the inertia force, it is always in line with the displacement. It is, what is the relationship between damping force and inertia force? Plus omega t minus phi plus phi by 2, omega t minus phi plus phi. Plus phi means it leads by 90 degrees to with respect to this damping force. So plus 90 degrees, again it is the, it is in phase with the displacement. So it is, the magnitude it is m omega square x or m omega square a. So now all the forces are shown in this graph. Now using this we will draw a force polygon. All the forces have the magnitude and also direction, so these are the vectors. By these vectors let us draw a force polygon. Okay, start with the spring force. Spring force, it is at angle omega t minus phi, or taking this line, a parallel line, this is kx. Okay, this magnitude. And next damping force, from this point we are drawing a parallel line, this is c omega x. Okay, next from this point we are taking inertia force, this is this omega t minus phi angle. You draw a parallel line from this point. So the remaining force you just connect it to the original point, that is impressed force F naught. Okay, this impressed force, it is at an angle omega t. Okay, you connect this point to the origin. Okay, now by this force polygon let us derive the response of the mass spring damper system. The magnitude of this is omega square, and this is kx, and this is c omega x. Okay, let us find what is response. Okay, by this triangle ORS, this is F naught, and what is the magnitude of SR? It is equal to the PQ. PQ, it is c omega x. This SR magnitude, it is c omega x, and this OS, it is total distance between P and O, it is kx. Up to this it is kx. Okay, minus this OS. Okay, that is kx minus m omega square. Up to this it is kx, and this is the distance between P and S, it is kx minus m omega square x. kx, the distance between OS, it is kx minus